top of my head. Do you know those ones where you saw the aircraft and you got the angle and then it moved and you found another angle and you found out how high up the aircraft was or how far away from the castle wall, right? If I see a question like that, just like in the homework, right, I'll pick something very similar. And so if you're looking at your midterm, if you look at your online tests and if you look at your homework, that's what you're going to see, right? These questions are chronological. The first multiple choice question, question 1, will be on stuff from week 1. And the last question you will see will be on the dot product, right, week 10. And section 2, the first question you're going to see is from week 1. And the last question you're going to see would be from vectors, right? So as you go through the test, it's like traveling through time, right? I'm in week 5 now, right? I'm almost at week 9, right? That's the last question, week 10, right? Kind of like that. I don't mean by that you get one question from each week. I'm just saying that chronologically, that's the order they're going to be. Okay. So let me now, if I can, show you some resources that will be available to you and ones that what you are and are not allowed to use. So give me a moment. Here we go. So I don't know if you've noticed this guy. I hope it's visible. It should be. You've seen this guy called Final Exam Module? Right. So here is the link to the Zoom. And why doesn't that have the other stuff in it? Okay, I'll fix that. But if you go here, there's the link anyway, right? So I was wondering why they were missing. We go with that. Zoom link. What else have we got? When you can click on it right now, nothing's there. But when you click on this one, this is where the final exam will be, right? It'll be a PDF and you can just do like in the midterm, right? You read the questions, you write the answer on paper, right? The multiple choice, I just say the answer, the other ones you don't. Here is a polar, the polar equation grapher. You know, if you've got a question, you want to draw a polar curve of some kind. I have no idea what I'll do. Put a 2T in there. It could be fun, right? Then just hit graph. And let's speed this thing up. There you go. Can you imagine a multiple choice question where they gave you a thing and said, which one of these graphs is it or something? You might want to use it for that or whatever. And I'm fed up doing that. So anything that's in here will still be available on the day of the final. You'll be using this guy here, right? And that just to remind you how to use it. But won't you use Microsoft Lens or Cam Scanner or whatever you used last time, or the printer, right? Your printer scanner, because all your working is going to be sent to me. And when it's sent to me, it's going to go here. So you click on this guy and then you'll hit start assignment. And then you'll either in OneDrive or file upload. If I hit upload file, I should be able to choose it. And you choose it and it's done. Submit assignment. That's it. That's how you get the work to me. Now, when you finish the final, you've got 3 hours to do it. You've got an extra half hour after that to get the pictures taken and uploaded. And you need to make sure that you check with me that it is actually okay. Because most people, it's fine. But last midterm, it happened at least 5 or 6 times. I looked at it, it was so faint, I couldn't read it, right? You have to do it again. Or what happened to, the last 2 pages? I can't see question 8 and 9, right? So it gives me a chance to scan through it and make sure that I can check it for you. And once I say you're good to go, you are finished. And then about 2 to 3 days later, I will have your grade and it will be put into CTC and you should be able to see your grade. And that will be it. Of course, you're all going to get 4.0s because I want you to, but that's asking a lot. But you're all going to do as well as you can. That's all I can expect anybody to do, the best they can. But if you can send me unmarked $100 bills, that would be good. I won't change your grade, but I'll keep the money. So that's good. Because I believe the loophole is that it's only bribery if you do something for it. So if you just give me money and I keep it, but I don't do anything, then it's not bribery. See, that works. You know, I'm joking.
Are we going to take the test with other classes again?
No. Let me double check. I think there's one pair of classes where that is true. And the answer is no. You'll be on your own, so just our class and nobody else.
Okay.
So hopefully that'll be less distracting for you as well. Any questions about what's here or not here? Because if you look at this, I have no PDFs of unit circles, for instance. So I'm just giving you some advice here. You can choose to take it or not. You know that you are allowed to have certain things. Let's go to the list here so we can talk about them. One that you're allowed is you're allowed to have any physical notes you want. So have a formula sheet with you or formula sheets. Have a unit circle. I can't think of any person who probably doesn't need a unit circle, right? So get a good version of it, print it out, have two in case you lose one, and have that. Have any notes that you want, right? So here is a list of all the things we're doing. So what you can and cannot do, let's make this a little bit bigger. You can use your TI-84 calculator. You can use Desmos and things like Desmos, right? Because that's in the Canvas. So if I put it in Canvas, it's good. If someone notices something that you think I should have there, shoot me an email. If I'm okay with it, I'll put it in case I miss something. Any written notes, totally okay with that. List of formulas, unit circle, go for it. You need things like that. Any resource.
Unit circle?
Say again?
The unit circle can be just a print though, right?
Yeah, I would print it. It's easy to work with,
Okay.
right? Just print it physically, right? And some people have Macs and things where everything is kind of, their notes are kind of written electronically. I'm okay with that as well, but most people printing is the best way. So let's look at what you cannot use. You cannot use any kind of calculator that has the ability to do what's called algebraic manipulation. Now, if you don't know what that is, then you haven't got that calculator, or you don't know how to do it because you never knew it had it. So you're okay, right? If you've got it, you will know about it because there are some calculators that will solve equations for you, right? They're quite expensive, but they do it, right? So, not allowed. Secondly, since I need to see you're working, would you agree a calculator that tells you the answer is probably not going to be much use because you don't know the working, right? So it won't take me long to figure out, nobody can go from the question to that answer without 8 lines of working in the middle. I haven't seen them, you're getting 0, right? So if I don't see working, it ain't happening. So you don't want that calculator, don't use it. You can't use the internet in any way except for the Canvas one. So you're not allowed to go on the internet and do searches. Oh, I want to search, how do you do this? Or I want to search blah, blah, right? Ain't allowed. You can't use it to go and look up tutoring or help pages, right? You can't go to a tutoring service and say, I need help with this question. That's basically getting someone else to do it for you. Not allowed. You cannot use any software except the stuff I've gave you, right? Because there are lots of different software out there if you go looking for them that do all sorts of stuff that I don't want you to be able to do because it's what you can do, not what some other person or some other software can do. You're not allowed to communicate with any human being, living or dead. Just put that one in. Or software or person by any means whatsoever. So I put etc. because you can't say, well, I didn't email the person, I used Snapchat, or I didn't do this, I used Twitter or whatever. That's still the same thing. Don't do it. WebAssign and Canvas, for the most part, will be gone. So if you go to WebAssign, all the homework will be it won't be visible anymore, right? It'll disappear. So that's gone. And you won't be able to do anything on Canvas like watch past videos because they'll be gone. So the only thing that will be left in Canvas is that final exam one, right? The one that we've seen a few minutes ago. Nothing else. Okay, any questions at this point now? Last chance? Maybe I'll come to you later. That's fine. Okay, so I want to pick for today. It's going to be kind of my topics for today, if you don't mind. A couple of the things that I've discovered, or I feel that we need to practice on. So find the darn page. You can never find things when you want them. Okay, you're hiding from me. Gotcha. Right, I'm going to be looking today at identities. So give me a few moments to find it. While I'm doing this, why don't you just do your attendance in case you haven't already? And give me a few seconds. I got it. Right, we are good. So here we are. Here are some examples of identities. The top batch are Simplify Me, and the bottom batch are identities. The only real difference is in an identity, don't they tell you what the answer is? And up here, you have to figure a way of simplifying it. These questions can appear in different places. If, for instance, I gave you a question from this bunch, 13 to 28, I'm assuming you can see what I can see, right? 13 to 28. Yeah. If I gave you them, I would do them in multiple choice. I would say, simplify this guy, and A would be the right answer, right? The simplest version. And then B, C, and D would be, you know, either mistakes or something that wasn't simplified enough, right? On the other hand, if I gave you a question like prove an identity, that would be in section 2, right? And you would show me the 5, 6, 7 lines. If you look at the first one, these guys up here, which is the ones I'm going to start with today, they are multiple choice. So you can, if you know the answer is sine X or sine T, you just pick B and you're finished. I don't need to see any working of any kind. So I'm going to move this guy over here, and I'm going to take you through some of the tricks of the trade for simplifying expressions. So let's take, for example, this just happened to be a question called 19. Secant squared x, take away 1, all over secant squared x. In identities and in this question here, we're being asked to simplify. You're using the same strategies, the same techniques. One useful technique is turn everybody into sines and cosines. That's a good starting point. Now, if you take secant squared, isn't a secant 1 over cosine x? That's something you would have down in your formula sheet. So won't secant squared be 1 over cos squared? Take away 1. And this guy could be 1 over cos squared x. Now, there's another way of solving this question, but I'm just showing you a kind of the bog standard method that tends to work no matter what the thing looks like. Now, this expression is completely, totally ugly. It's a fraction with fractions on the top and fractions on the bottom, which is not that uncommon. So what you now do is you try and make your fractions nicer. And I'm going to do that by multiplying by a special version of 1. And the special version of 1 that I'm choosing is cos squared x. Now, if you multiply this guy by cos squared, you get 1. If you multiply -1 by cos squared, you get negative cos squared. If you multiply this by cos squared, you get 1. So I'm now at that stage. Did you see it came out quite nice? And if this was a multiple choice, one of my answers would have been this one. But it's not the simplest answer. What can 1 minus cos squared be simplified as? 1 minus cos squared. Sine squared. So over here, what have I used? I've used the fact that secant can be written as 1 over cosine. And I've used the fact that 1 minus cos squared x can be written as sine squared x. They're very common identities that you will write down and use as necessary. Okay. Now, I said you could do this one other ways. So let's show you a different approach. I'm going to get the same answer, but just a different way of doing it. Secant squared x take away 1 is tan squared x. And there are other combinations of this. Secant squared x is tan squared x plus 1. And another combination of this guy, if I can figure out what it is secant squared x take away tan squared x is equal to 1. They're actually the same information, just rearranged in different ways. So the top guy is tan squared x, and the bottom guy is secant squared x. So far, so good. Now, if you do tan squared, isn't it sine squared over cos squared all over cos squared x? So where shall I put that one? I'll put this one here. That tan x is sine x over cos x. And then if you look at these two guys, they cancel. And guess what? You get sine squared x again. And if I thought about it, I could probably come up with another version of how to do this question. Right. Let's pick another simplify one. Okay, how should we do this time? This one's called question 22. I have a 1 plus sine y and 1 plus cosecant y. I'm going to do the turn everybody into sines and cosines. I'm going to call everything in x's here. What can cosecant x be written as in terms of sines and cosines? 1 over what? Cosecant x.
1 over sine.
That's right. So this becomes 1 over the sine of y. So far, so good. Now, same kind of problem. We have a fraction with fractions in it. And the way you get rid of fractions that have fractions in them is to multiply by a special version of 1. Do you see in this case, I'm going to use sine y. And whatever I do at the top, I do at the bottom. Okay. So I'm going to leave this guy as a multiplication right now. And I'm going to multiply this by sine y, and this guy by sine y, and I get that. Can you see anything nice that's going on in this question?
The top 1 plus sine y plus 1 are the same thing, so they cancel out.
And would you agree that if you get to sine y, you're probably as simple as life is ever going to get, right? So you know you're finished. So have you seen, at least in the 2 examples I've done, hasn't the trick of turning everybody into sines and cosines is a good starting point? Even although the algebra that comes after it might be messy, at least it's a good place to begin, right? Turn everybody into a sine and cosine. So let's do one more of that type, and then I'll show you a different situation. 2 plus tan squared of x over secant squared of x, right? What could I turn tan squared x into?
Sine squared over cosine squared.
So it's pretty much very similar to the ones we've done. I don't know, it's bad luck that we got cosecant, but I guess it's very common. Right, would you agree that that's what you get when you turn everyone to sines and cosines? What special version of 1 will I multiply this big ugly fraction with to make it a prettier fraction?
Cosine squared.
Have you noticed that the magic value, the special value of x is always whatever's on the bottom, right? If I was trying to get rid of a sine squared, wouldn't this be sine squared over sine squared? If I was trying to get rid of a single sine, wouldn't I do sine over sine, right? So that's how you know that one. Now, if I multiply the top, that guy, I get 2 cos squared x plus a sine squared x. And if you multiply them, you just get 1. So in this case, I have 2 cos squared x plus sine squared x. And that is a really nice answer, but I can make it better. Not much better, but a little bit better. Any suggestions?
Sine squared plus cosine squared is equal to 1. Yeah.
Now, I have 2 of these guys, agreed? Not 1, but I've got 2. But if I think of that as being a cos squared plus a second cos squared, wouldn't I have a cos squared x plus 1? Does that make sense? Do you need to see the middle line, or can you figure out that the sine squared plus 1 of them gets you 1, but there's still a cos squared left? Right. Would you agree that that's as good as that's going to be, right? And since these are typically multiple choice questions, you would see that as definitely your answer, right? That would be one of your choices. Like this would be one of your choices. So let's now show you a little bit different and a lot scarier. Let's find a ugly fraction. Here we go. How about 1 plus sine u over the cosine of u added to the cosine of u over 1 plus the sine of u. And now that I've written that, don't write this down unless you really want to. I should have gave myself more space. There isn't turn everybody into sines and cosines here because everybody already is a sine and a cosine, right? So we know that method's not going to take us anywhere. I do, however, have 2 distinct fractions. And since I want to simplify this, it's pretty much guaranteed that don't I have to join them together to make one fraction. And that's where the fun is going to start. I am going to multiply this fraction by a special version of 1 and this one by a different special version of 1. I want to add two fractions that do not share the same common denominator, right? It's like halves and thirds. So I have to turn them both into like sixes, right? Sixths. So I'm going to take this guy and multiply it by 1 plus sine u over 1 plus sine u. You agree that's one. Now, what do you think I'm going to multiply this fraction by? Because it's not the same as that one. What will I
Cosine u over cosine u.
Can you see that it's not just random? Can you see there's kind of logic that you use the bottom here on this guy and the bottom here on this guy? You see there's a kind of switch over, kind of, I'll use what you've got in the bottom and you use what I've got in the bottom, right? That kind of thing. Now, we have a common denominator now, which is cosine u 1 plus sine u. And I'm just going to leave it like that. And on the top, I have a 1 plus sine u times another 1 plus sine u. And I have a cos times cos, which I'm going to call cos squared u, right? So I'm taking this nice and slowly. I'm not going to do anything to the bottom. Probably never will. Except write them down again. Foiling this out, you will eventually get 1 plus 2 sine u's plus a sine squared u, and then you've still got add cos squared u. Anything going on there that might be nice?
Sine squared plus cosine squared is equal to 1.
Agreed. And to save a line of working, can I take this one and add it to that one and get 2?
Yep.
So now I've got 2 plus 2 sine u all over whatever's on the bottom. Sometimes you're finished, but not here. Is there anything you can do to the numerator that might get it nicer?
Do you want to factor out the 2?
Why do you want to do that? It's the right thing to do, but why?
Because then you can divide because you're multiplying. You can cancel out the 1 plus sine u.
Do you see that, guys? Right, if you pull out a 2 as a common factor, this guy gets killed off by this guy. And now we are looking at 2 over the cosine of u. And that is a very, very nice answer. But we have a rule in trig that basically says we don't like fractions. So write it without being a fraction. And I'm using the fact that isn't 1 over cosine the same as a secant. And that is you finished. Are we good? Then let's move on to identities, because it's the same kind of process. The only difference is identities tell you what the answer should be, which in a way is helpful, right? Because you know you're finished because your answer is the same as the right hand side. So an example of an identity. Okay. Pick something vaguely interesting. That's weird. I have 1. Now I'll wait till later for that one. Change my mind on this one. Let's do this one. 2 sine x cosine x all over sine x plus cosine x squared, take away 1. Now we have to prove that it's equal to 1. So that ugly mess, somehow or other, is going to be just 1. Not going to do anything to the top line. What do you think I'm going to do to sine x plus cos x squared?
FOIL.
Yes. And it's important that you, and that's why I'm writing it down like this, that you realize that it's FOIL. So you're doing an F, an O, an I, and an L. And when you do that, you'll get this. You'll eventually get a sine squared x, 2 lots of sine x, cosine x, plus a cos squared x minus 1. So why am I labouring the point? A lot of people, unfortunately, see that and think, oh yeah, there's a quick way. It's just sine squared plus cos squared. You see they only take the first and last term. Do you notice that if you do that, you'll miss this term? Sine x plus cos x is squared is not sine squared plus cos squared. I wish it would. It'd make algebra a lot easier, but it's not. Just not equal to it. Can anybody see anything that we could do next? I'm thinking about on the bottom, the denominator.
You could cancel out the ones because sine squared plus cosine squared is equal to 1.
Okay, let's see what you're saying. Those two guys add up to 1, which cancels out with this one, right? So if I wrote the line, wouldn't it be 1 plus 2 sine x cosine x, take away 1 and then cancel? But if you can see that in one go, that's great. For some reason, I'm slightly out of sync. Oh, wait a minute. Isn't this the same as that? Can you see we got one? Now, when you look at that, would you agree that you'd be a great guesser if you said that, right? Oh yeah, I can look at that and tell you the answer's 1. Would you agree? Very few people, including me, could look at that and say right off the top of their head it's 1, right? So it's a useful skill to be able to prove that some ugly expression is equal to something a lot nicer. Now, there's all sorts of weird stuff floating about here. I'm just trying to pick something. I've no idea where this one's going, so that's why I'm picking it. Cotangent squared. Let's try that again. Oh, that's what my problem is. Cotangent squared of t. That was a bad choice of letting. Take away cosine squared t. And according to them, that guy, take away that guy, is going to be cotangent squared t cos squared t. Let me double check that. Cotangent squared, take away a cos squared, is going to be a cotangent squared, yeah, times a cos squared. Now, in many identities, don't you have an ugly guy equals something nice? Which again, in this case, we have an ugly guy equals a different ugly guy, right? So you could go one of two directions. Both are correct. Couldn't I take this and eventually prove that it ends up looking like that? And that would be a valid proof. Or couldn't I take this guy and eventually make him look like that? There is a third possibility. Couldn't I take both sides and get them to meet in the middle? In other words, change this a little bit and get something. Change this a little bit and get the same something. Wouldn't that also be a proof, right, that the left is the right? So let's start with this fella then. I'm going to resort to turn everybody into sines and cosines. Not saying this is the only way, but if you can't think of something, it's a good way to start the day. Now you got that? So far, so good. And somebody should tell me something that I've done wrong because I can see it. What have I done wrong?
It's cotangent, so it's cosine over sine.
Okay. Glad I caught myself here. Okay. That does not look like that, or even vaguely like that. We've came across this problem slightly differently. Don't we have a fraction take away something that's not a fraction? But don't I want to join them together? Why do I need to join them together? Isn't this a single thing, right? It's not made up of two pieces, it's one thing. So I am going to take this fella, pretend t is cos squared over 1, and I'm going to multiply him by sine squared t over sine squared t. So I now have a shared common denominator of sine squared t, and I have cos squared t, take away cos squared t times sine squared t. Are we good so far? Follow the logic. Take this and turn it into a fraction over sine squared. Right, look at the top row. Anything you can do on the top row?
Can you factor out a cos squared t?
You can. And that will leave me with 1 take away sine squared t. Does anybody recognize that 1 take away sine squared t can be turned into somebody?
It's also equal to cosine squared t.
And now I'm going to stop my temptation of combining these two. Wouldn't it be quite tempting to just say cosine to the 4th t over sine squared, right? But I'm not, because I know what the answer should look like. What I'm going to do instead can't you split it like that? What do you call this guy? Cos squared over sine squared. What's his name?
Cotangent squared.
Yeah. Wait a minute. Isn't that what we're trying to prove? So we finished. So I've taken this left-hand side. I got to here, and then I recognize that if you've got, oh, by the way, you might be thinking, shouldn't that sine squared be both of them? No, that's not how this works. If you've got a guy on the bottom, can't you give it to the first one and just separate it from the second? So I'm pushing this over to this side, keeping that on its own, and then combining these two. Because technically speaking, isn't right now that times that over that the same thing as this? Great. AB over C, right? You can do AB and then do the C. We're finished. Yeah, let's do, oh, where shall we go? There are so many fun ones. What one shall I pick? This one. Sine to the 4th theta, sine to the 4th power of theta, cosine to the 4th power of theta, sine squared theta, take away cos squared theta. Last one for today. No two identities are exactly the same, right? Some are quite similar and you do the same things, and some are just weird, right? And they're unique in their own way. This one here I would call unique. So we're going to return back to this, but I want to show you a little piece of algebra. If I had x to the 4 take away y to the 4, mathematically, that is considered the difference of two squares. And the only thing is that the two squares are themselves squares. Can you see it's x squared plus y squared, x squared minus y squared. If I FOIL that out, can you trust me that you get that? So this technically is a difference of two squares. It's a difference of two squares. Right? That's bad English, right? But that's what it is. So if I think of this as x to the 4 and I think of this as y to the 4, then shouldn't I be able to factor it as sine squared theta plus cos squared theta, right? Like x squared plus y squared, multiplied by sine squared theta, take away cos squared theta. You see the analogy between this and that? A fourth power of a sine, take away a fourth power of a cosine, can be written as these two guys times these. And if you're not convinced, FOIL it out and I bet you get that. Now, is there anything out of either of those two pieces that you would be able to say, I can simplify something into a nicer guy?
Well, sine squared plus cosine squared is equal to 1.
And won't that just leave you with then 1 times this guy? Wait a minute, isn't that what we're trying to prove? But the leap was figuring out how to do this, right? Now, if you did figure that out, wasn't this a 3-liner, right? Question, factor, answer, right? That's how quick it was. But you kind of have to think outside the box. Okay, let me just fixate on this a little bit. That guy also counts as a difference of 2 squares. You're probably not going to get an identity like that, but let's pretend we did. How would that one factor?
Is that x cubed plus y cubed times x cubed minus y cubed?
And trust me, FOIL it out if you don't believe me. Can you see a pattern here yet? Last one then. You definitely wouldn't get an identity with 100 power in it, but pretend you did. What would that one get you? There's a pattern going on here. When it was 4s, right?
X to the 50 plus y to the 50, and then x to the 50 minus y to the 50.
For those who still can't see it, where are you getting that 50 from?
Well, when you multiply exponents, you just add them together. So essentially, you just split it in half.
Yeah. Half of that guy, half of that guy, half of that guy. See the pattern now? 4 gets you 2, 6 gets you 3s, 100s gets you 50. And that is us for today. Have a nice day, everyone. Tomorrow and Thursday, it's for you to tell, well, let me redo that. I want to do equations, but it's also for you to tell me what you want me to go over, right? So I'll do a couple of equations, solving equations, and then you tell me and we'll do it. Okay, bye-bye from now, guys, and I will see you tomorrow. I'll hang about for questions.
Thank you. I had a question sort of about the homework. It's not about one. So you added problems, right?
Uh-huh.
I added those, and then you took some of the problems away.
Yeah, I was in the process of figuring out what I wanted that section to contain.
Okay.
It shouldn't matter too much because I did rescore them, I hope, which means you know, it should be 100% if you did everything right.
Oh yeah, all the questions that are there are correct.
Okay.
I was just wondering because we covered one of the problems in class and then it wasn't there. So.
Yeah, well, after I covered it, I figured out it wasn't worth the trouble. Oh, there were some questions I didn't put in that went the other way. Remember, I did questions where you had 3 points and you had to find all the angles and sides. But none of them are in the homework. They take too long. If I put a couple of, I was saying, I think to one of our students, if I put a couple of those questions in, that would add close to an hour, just because of that. The fact I didn't put them in the homework doesn't mean I couldn't put them in the test.
Yeah.
Because I know you've